Okay, in this problem we're going to look at the normal distribution and how to solve problems using Excel. The question says, suppose battery lifespans are normally distributed with a mean of 400 hours and a standard deviation of 40 hours. What percent of batteries last less than 350 hours? That's part A. And then a battery selected at random, what is the probability it would last between 360 and 400 hours? And finally, an engineering project requires the batteries to be in the top 10% of lifespans. That means the 90th percentile or more. At least how long should batteries last to be in the top 10% of lifespans? So that question is going to involve kind of going backwards. But let's look at the first part A. We want to know what percent lasts less than 350. So in an empty cell, click on FX and scroll to get on statistical and scroll down to normal distribution. And click OK. Once you see that, you'll see these function arguments. X is the number we're looking at. We're looking at 350 hours. What percent lasts less than 350? So 350 we put in for X. The mean of this is 400 of this distribution. The standard deviation is 40. And the key thing here is cumulative. What do you want? We want the cumulative function. We do not want the probability density function. If you were interested in experimenting, that density function can be used to graph that bell curve. But we actually want to use the cumulative distribution function. So we have to type true in here. Okay? And we click OK. It gives us the percentage. What percent lasts less than 350 hours? Well, that's the probability, 0.10565, or the percentage as a decimal. And as a percentage is 10.57%. And make sure this is a normal distribution. Remember that. This is a normal distribution. So that's why we could use this function. Second question, battery selected at random. What is the probability it will last between 360 and 400? Well, we have to note that the function only gives us the percentage less than the value. So we need to calculate two things here. We need to figure out what percent less than 360 and what percent less than 400. Now you may have noticed that 360 is actually one standard deviation below the mean of 400, and I know from the empirical rule that within one standard deviation is 68%. So one standard deviation below, that's just half of that, would be 34%. But we will still calculate this using the normal distribution function here. So click on FX, statistical, scroll down to normal distribution, click OK, and put in your what arguments. We want less than 360. The mean is 400. The standard deviation is 40. And cumulative is true. And that gives us the amount less than 360, which is 0.15865655. Less than 400 should be 50%, right? But just so we emphasize that, I'm going to actually copy this function from here and copy it back into that cell here, so I don't have to look for it. The only thing I have up here in the function bar, I have to change that value from 360 to 400, and so we see it's 50%. So we need to find the difference between these two. So we're going to have equal the larger percentage minus the smaller percentage or smaller percentile, and that's my answer. 0.34 probability. 0.34 probability, which we saw 34% originally. Okay, part C says what should it be to be in the top 10%? What value is the top, cuts off the lower 90 from the top 10? So remember, actually we're looking for the 90th percentile, so you might want to make a note of that. But we're actually going to find the value, not even the z-score. We're going to go straight for the value. So we click on FX, statistical, scroll down to normal, but inverse normal, and just look at what it says here. The probability. Well, what's the probability? 0.9. That's the 90th percentile. The mean is 400, and the standard deviation was 40. And so it gives us the inverse norm, right? So 451 hours is that cutoff value of lifespans, cutting off the top 10% from the lower 90%. So you'd want to have batteries that last 451 hours or more.